Hi, Open XML developers. This is Eric White. Today I am introducing a new module called FormattingAssembler. This module, FormattingAssembler, is in PowerTools for Open XML. It's a module that helps us to determine for any given run, is that run bold? What font does that run use? For any given paragraph, how much white space is there before the paragraph? How much white space is there after the paragraph? How is the paragraph indented? Is there a hanging indent or is the first line indented? This problem of determining what the formatting is for a particular paragraph or for a particular run, it's not that easy of a job. If you are looking at a particular paragraph and you want to find out how it's formatted, you might look first at the direct formatting on that paragraph. That might tell us whether the paragraph has a certain amount of space before it or a certain amount of space after it. But if that direct formatting doesn't define some particular aspect of the formatting of that paragraph, then we might need to go look in the paragraph style. But not only that, that paragraph style could inherit from another paragraph style, and so on. This chain of paragraph styles can be as long as you want it to be when you are composing an Open XML document. And finally, if we don't find some particular aspect of formatting in the paragraph style chain, we might need to look in global defaults. If we take a run, the run has a similar type of issue. We might first look at the direct formatting of the run, and if we don't find a particular aspect of the style, in other words, whether the run is bolded or whether the run is in italic, then we might need to look at a character style, and that might derive from another character style. And ultimately, we may need to go back to the global defaults to find out whether that particular run is bolded or not. Tables get even more interesting. A table can have a table style with conditional formatting. And table styles with conditional formatting are pretty involved. You can define formatting for such components as the first row, the last row, the first column, the last column, odd rows, odd columns, even columns. You can define styling for any of the four corners of the table, in other words, upper left, upper right, and so on. And to make it even more interesting, you can, for any given table, apply only certain aspects of the table style. You might format a document such that for a particular table, the top row or the bottom row doesn't use formatting from the table style. And table styles can also inherit from other table styles. Finally, when we're looking at a paragraph in a cell, we might need to go look at the paragraph formatting for that particular paragraph. And again, we need to look at the direct formatting, the paragraph style, and the global defaults. For any given run in that table, we also need to look at the run properties and its direct formatting, character styles, and global defaults. It gets even more involved when you consider numbering. Each list item in a numbered list has styling. The styling might come from the paragraph. The styling might come from the definition of that particular numbering format, and the styling might come from a style that numbering format points to. To throw into the mix, we also need to consider themes. The net result of this is that to determine whether a given run is bolded or italicized, or whether that run uses this font or that font, it's a fair amount of code to determine that. All of this information is there in the OpenXML standard. It takes a little bit of work to suss out all of that information and figure out the code that you need to write. But fortunately, we now have a module that will do this work for us. Let's go take a look at the operation of this module. Here I have the zip file for the core part of Open XML PowerTools version 2.3.0. You can download this zip file from powertools.codeplex.com. If you go to the Codeplex site and you click on the Downloads tab, then scroll down to the bottom of this page here, and you can find PowerTools Core 2.3.0. Let's unzip this zip file. Let's go run these examples. Double-click on the examples directory and then open up the Open XML PowerTools example solution. First thing let's do is let's rebuild the entire solution. If we look in the Open XML PowerTools examples formatting assembler example, we see three source documents. Let's look at test01.docx. We can see a simple document here. We can see that this line up here is formatted with the title style. This line is heading 1. This line is heading 2. This paragraph here is normal, but right here we've got a run that is formatted with the strong character style. This run is formatted with the quote character style, and this run is formatted with the intense character style. Let's close this document and we'll run the example. And now if we go into our directory of that example, we see that there is now test01out.docx, and same for test02 and test03. These are the documents that are produced by the formatting assembler. And let's open test01.docx and test01out.docx. Here's test01.docx. And here's test01out.docx. And they look exactly the same. But what you'll see up here is this is no longer formatted with the title style. And this is not formatted with the heading 1 style. And this is not formatted with the strong style and the quote style and the emphasis style. These are all just paragraphs that have formatting directly applied to those paragraphs and to those runs. Let's go look at the markup so I can show you exactly what I mean by this. I'm going to look at these documents in the Open XML PowerTool package editor for Visual Studio 2010. So let's first look at test01.docx. I'll open the main document part. I'll format the XML, and we can see that this first paragraph is formatted with the title style. Here we can see the paragraph has some runs that are formatted with the strong style and the quote char style and the intense quote char style. Now let's look at test01out.docx. And what we're going to find here is that the first paragraph no longer has the title style applied to it. Instead, it just has a number of things defined for the paragraph property, such as spacing and contextual spacing and the run properties for the paragraph properties. And down here, we can see this run. We can see it is formatted with Calibri Light. And in these run properties, we can see that there's a certain amount of spacing, there's kerning values, there's the size of the font, and then finally we can see the text of the paragraph. Dropping down further, here we can find the run that was bolded through the use of a character style. And in this particular case now, we don't see a run that points to a style. Instead, we just see this bold element here and the BCS element here that define that this particular run is bolded. What the formatting assembler did is it went through every paragraph and run in the entire document, and it looked at the style names. It rolled up those styles, assembling all of those properties from the style chain, and it put together the exact right, appropriate, direct formatting for every paragraph and every run in the entire document. And then this entire document, it doesn't refer to any styles. It's just a document that has some paragraphs and runs in there that are formatted as we want them to be formatted. So your question might be, why do you want to do this? And there are a couple of different reasons. One is that we want to write a really high fidelity, nice transform to HTML. And by first doing this transform, the next transform to HTML that is styled with CSS, that's going to be a breeze to write. We don't even have to pay attention to style names or anything. We can go through and generate the HTML and CSS directly from the paragraphs and runs in this document that has the assembled formatting. As I mentioned, there are two reasons we want to assemble this formatting for a document. The first being transform to HTML, and the second is that there's a situation where you can use a custom font in a document, and the normal course of events is that you embed that font in the document if you use a custom font, but the end user has the option to not embed that font in the document, and if they do so, then when distributed to people who don't have that font installed, results in a document that refers to a font that isn't on the user's machine who is viewing the document. You might have a corporate standard where you specify that only certain sets of fonts should be used in documents, or you might have a requirement that no embedded fonts be used in the document, and you almost certainly would have a requirement that if a user uses a custom font, that if the font is not a standard font, it should be embedded in the document. So you want to find out what font is used for every run in the document. Let's look at test01.docx. Here we can see, again, it's formatted with the style of title. And if we go over here and we find the title style right here, we can see it's linked to the style title car. If we drop down here, we can find the title car style, and we find this R fonts element that defines 4 fonts: the font for ASCII, East Asia, HANSI, and CS. In this particular case, it's specifying that the font should come from the theme of the document. The Open XML standard states that the way you determine which of these fonts will be used is based on the code block of the character in the run. If we look in the interoperability documents and we look inside this document MS-OI 29500 and we navigate to section 2.1.87, which contains the interoperability documents on the R fonts element, we find this text here that specifies exactly how you can find out which font to use given the code block of the Unicode character in the run. If the character is in this range, in other words, it's in the basic Latin Unicode block, it uses the ASCII font or ASCII theme font if defined. If the character is in this range, then that means it's in the Latin-1 supplement Unicode code block, and you use this algorithm to determine which of the 4 fonts should be used for rendering of that character in the run. We can drop down through here and we can see that the algorithm to determine the font to be used, it's relatively elaborate. Let's go look in the FormattingAssembler module. In that module, we can find this method, adjust font attributes, and this calls this method determine font type from character. If we look at this method contains the entire algorithm as defined in that MS-OI 29500 document. We can drop down through and we can see the details of this algorithm. It's a direct representation of the text in that interoperability document. And what the formatting assembler does is it puts a special attribute on every run in the produced document. Let's go take a look at that. I'll drag test01 out.docx onto the package editor. Let's go look in the main document part. And what we can find on every run, there is this PT14 font name on the run. And this font name was derived from all of that information. So it took the various attributes of the rfonts element defined for that run, and it figures out which exact font should be used for that run. This PT14, that's the namespace prefix that is for this special namespace, powertools.coplex.com/2011. This is not an Open XML namespace. This is a PowerTools namespace. And this ordinarily would make this an invalid document. But as you can see, I put that PT14 prefix in the MC ignorable attribute on the root element of the document. And therefore, Word or any conforming consumer will not complain when you open this document because it'll ignore all attributes that are in that PT14 namespace. Now, you have to be aware that Word will not round trip that PT14 namespace. If you open up that document, Word won't complain about it, but if you resave that document, that PT14 font name attribute will be lost. But really, we're more interested in using this output document from FormattingAssembler either in our transform to HTML or for analysis of font usage. We don't really want to enable the end user to edit the document. They can. It's a valid Open XML document, but that's not the purpose of this document. The purpose is for analysis. So therefore, we can go into that document and we can find every run in that document and we can look for the PT14 font name attribute and we can find out which exact font should be used for that run. So main point about this is it's a fair amount of work to figure out exactly what font a particular run should be rendered with. And by letting the formatting assembler do all of the heavy lifting for us and then putting this little attribute on each run, it makes it easy for us to figure out which font should be used for each run in the document. Let's look at test02.docx and see what there is to see about that example. This document has numbered lists in it. So for instance here, this heading 1 style is styled with this particular style right here. And so therefore, the heading 1 has this article 1 prepended to it. That's the list item for that paragraph. And also heading 2 has section 01.01. Heading 3 has this parenthesis A, close parenthesis. Dropping down here, we can see some other numbered lists. Here we have a list that is numbered with first, second, and third. We have a list numbered with 1, 2, 3. We have some bulleted lists here, and we have a list that is formatted with legal numbering. Now let's look at test02out.docx. And when we look at this document, it looks again exactly like the other one. Here's one, here's the other one. But this one, this is just ordinary text. This is also ordinary text. So is this, so is this. Even these bullets, these are just characters that are rendered in their special character font so that we get the exact same characters that we'd see if we saw the list that was rendered as a bulleted list by Microsoft Word. And the same thing is true with this list that is formatted with the legal style. Let's go look at the markup for this test02out.docx. I'll drag it to the package editor. And what we're going to see in this document is, so for instance, here we have that Article 1 here, and this was generated from the information that was defined for the numbered list that was set on those heading 1, heading 2, and heading 3 styles. And the formatting assembler went into all of the appropriate places and found out the font size and found out the appropriate colors. It then inserted a tab as appropriate, and then we can drop down further and we can find all of the formatted runs for the rest of the document. The same thing is true down here. We can see that here is the list item for the list that had first, second, third. And right here we can see that this is now in the document as plain text. It's no longer a numbered list. I have to tell you, it was a fair amount of work to get all of this to transform very exactly and very precisely in this fashion. The way that the formatting assembler implemented this functionality is it used another module in Open XML PowerTools called the list item retriever. This module has been around for quite some time. The old HTML converter code uses this exact module to render numbered lists appropriately. Some time ago, I wrote this MSDN article working with numbered lists in Open XML WordprocessingML. And this MSDN article goes through in precise detail into exactly how the markup for numbered lists works in Open XML WordprocessingML. The list item retriever implements the algorithm that is described in this MSDN article. Let's look at test03.docx. Here we have a number of tables, and these tables are formatted with various table styles. So for instance here, if we look at this, we can find that this table is formatted with grid, table 5, dark accent 6. This table is formatted with list, table 5, dark accent 1, and so on. Let's close this down and let's look at test03out.docx. And here are those tables, but now they aren't formatted with any table styles. Instead, they're just formatted with direct formatting on the cells and direct formatting on the paragraphs and runs. So now that we've gone through that work, the transform from this to an HTML table with appropriate CSS formatting, that's far, far easier than attempting to transform a table that has a table style on it, and that table style might be applied conditionally to this particular table, and that table style might derive from another table. It's fairly involved. So by transforming it from this other document that used character styles, paragraph styles, and table styles into a new document that has simply paragraphs with formatting on them, runs with formatting applied to them, and tables with table cells with formatting applied to them. We can then in the future do a transform to HTML in a much easier fashion. There are a few limitations to this formatting assembler module. First of all, it doesn't have right to left language support yet, nor Asian language support yet. These are both super important to me. I will be working on these in the very near future. It's just a lot of work, and we want to make sure that we get it really correct. In addition, there are limits to support of numbered lists. That numbered lists have support that varies based on languages. So, for instance, there are special numbering systems for Asian languages and special numbering systems for RTL languages. And the module doesn't have support for those yet. But again, this is super important to me. I want to make this transform be as accurate as possible for as many scenarios as possible, and that includes getting rid of these three limitations. I'll be addressing these in future screencasts. I know that the formatting assembler, it's not particularly important to most developers right now. I know that there are a few developers out there who will really need to know about this particular module straight away. However, once we get the high fidelity transformed to HTML, I think that that's going to be useful to an awful lot of Open XML developers out there. Thanks for watching. See you next time.